AP Stats is lesson 3.2b. We're going to talk about residuals and a little more about the least squares regression line, finding it using just means and standard deviations, our numerical summaries and summary statistics for data. Let's get started.
All right, we're talking about residuals of the least squares regression line. Remember, least squares regression line is our predicted line for a data set. So to calculate the residuals, you're going to use this equation where the residual equals our actual bit of data for a single observation minus the predicted value at that explanatory variable. Okay, so when we have a negative residual, we call that an overestimation, meaning our actual value is less than the predicted value. When we have a positive residual, it means we underestimated. So what that looks like is, let's say we have our data, maybe let's erase that, and our least squares regression line goes through, and let's say we pick a point here. Well, the distance here, we have our predicted value here, y hat, for some particular explanatory variable, and then we have our actual value. Okay, this value is negative because a is less than p. For here, we have another y hat, and we have a different actual bit of, oh, that's too much. We have our actual, oh, come on now. We have our actual bit of data and our predicted value. And because the actual bit of data is larger than our predicted value, our value is positive. So if you look here, we have some data for time sprinting and then a long distance jump measured in inches. So there is a regression equation for this bit of data, for this collection of data. It's y hat equals 304.56 minus 27.63 x, where x is our explanatory variable, negative 27.63 is our coefficient for that variable, and 304.56 is our constant. Okay, so we're looking at find and interpret the residual for a student who had a sprint time of 8.09. That's right there, we circled that already. What do we predict that their long jump distance will be? So we replace x with 8.09, and we get 81.033. Okay. Well, this is our predicted value. This, and 151 is our actual value. So we're going to calculate the residual, 151 minus our predicted value, and we get 69.96, 69.97. So we underestimated, okay, because our residual is positive, his long jump distance. Now, in the event that we do not have a set of data, but we have a summary, we have our data summaries, we have means, and we have standard deviations, we can in our value, we can calculate, or we can come up with our equation. What this is saying here, if we know the mean, x bar, and the standard deviation of x, our explanatory variables, we know the y bar and the standard deviation of y, and the correlation, these are basically this is our numerical summaries. These are statistics. For our data, we can come up with the equation of the least squares regression line. So first, remember, these are some things we need. So this is our least squares regression line equation. This is how we find the slope, and this is our y-intercept. We're just manipulating the equation at this point. So real quick here, SY is the standard deviation of the y's, and this is our standard. SX is the standard deviation of x. And these things are all in the formula sheet that you get when you take the AP exam. We're able to find this information because something is true. All least squares regression lines run through the point x bar, y bar. So we can use this information to manipulate our equation to solve for some things. So we actually plug x bar and y bar in here. Why do I keep using the highlighter? Sorry. In here, and that's how we're able to solve and get our y-intercept b naught. Okay. So from our example with used Hondas and the price of a used Honda as a response variable, and the miles of number of miles driven in thousands of miles was our explanatory variable, we have some statistics. So we have x bar equals 50.5 right here. And we have the standard deviation of x they give us as 19.3. And then we have y bar equals 14.425. And the standard deviation of y they give us as 1,899. And then we have an r value of negative 0.874. So using what we were told right up here, using these equations first, we can solve for our slope using b1 equals the residual times sy over sx, standard deviation y, standard deviation. Let's just plug those values in. We get negative 0.874 times 1,899 divided by 19.3, and that gives us 85.996. So 85.996. B naught equals our, let's see, 14.425, our y bar, minus our slope, that's a negative number, negative 85.996 times x bar, which is 50.5, and b naught equals 18,794.798. So we have two of our values so far, and that's all we need. We're looking for, if you remember, b naught and b1. So now we have y hat equals 18,794.798 minus 85.996x. And this is our equation for the least squares regression line. So let's answer the question: what would change in what change in price would occur, or should we expect for an additional 19.3 thousand miles? So we're going to use our slope times our explanatory variable, which is miles. And we should expect a change, right? That it's going to drop an additional. So, sorry about that. That this is the expected change we should see. It's not asking what the new price will be. It's asking about the change. So we'll say price will drop. The price will drop $1,659.72 for each additional 19.3 thousand miles. Now, there's something down here that's interesting. It said, what would happen if we standardize both variables? So we standardize our our response variables and our explanatory variables. Well, the standard normal, right? They're saying like this information, this data is normally distributed, I think is the assumption here that we're making. We change them all to z-scores. So remember, a standard normal has a mean of 0, standard deviation of 1. So from our other equations, right? So we have b1 is our r value times standard deviation of x. Well, that's 1. Or y divided by the standard deviation of x. That's 1. So our r value, our b1 is just our r value. Our y-intercept is b naught. That equals 0 minus b1 times 0. And so that's just 0. Our y-intercept is 0. So that, which makes sense. if they're both standardized and the mean is 0, it's going to go through the point 0, 0, because x bar and y bar are both 0. So there's one last thing, and we're going to talk about, whoops, no, I'm going to use the highlighter, the S value. Now, what is the S value? The S value is, we'll use a sub r, it's the standard deviation of the residuals. And there's a way to find this on your calculator. You just use stat calc single variable stats, and then you have a list for your residuals, and you find all your summary statistics for your residuals. And so by hand, if we were going to do that, it looks like this. It's the sum of your residuals squared, which should look familiar, divided by n minus 2. What that really is it's the sum of your individual y variables, the y actuals, minus your predicted y's. You're squaring that, and you divide by n minus 2. This does have units, and this will tell us how well our line fits the data. Basically, it's saying how well are our predictions. So what we want, this is going to be tough here as a visual. So let's go. We have our data here. Our R value tells us the strength of the linear relationship between the two variables, between our x and our y. Okay, explanatory and response. We want, pretend this is 3D. In theory, maybe I should try drawing it the other way. That was not any better. In theory, our values, our predictions and our data should fit, which should be normally distributed at every time we make a prediction along our regression line here. Okay, this is our regression line in black, our data values in red, and then our blue is basically how well our predictions fit the data. And it'll give us units. So we're saying in the examples that we were using with the price of the Honda, so using our Honda data is the prices, the actuals minus predicted values, and then we're squaring that, and then we're adding them all up for each of the values. So we get an x bar of 0. It's like 2.5 times 10 to the negative 10. And then we get a standard deviation. This is what spits out in your calculator. $5,545.49. What does that mean? Well, we should expect that our predictions, 68% of our predictions, should fall within one standard deviation of our regression line. So, and then 95% of our predicted values should fall within 2 standard deviation of our regression line. So imagine there's like a little tiny, so I was drawing this over here, little tiny normal curve above our regression line, our prediction line. Okay? And typically will be 1 standard deviation away, 99.7%, should have 3 standard deviations. So looking at our data, we had one residual of negative $7,662. And so the question is how good of an estimate is our predictor, right? We overestimated the cost of that Honda CRV by $7,662. Well, is that typical? Well, yeah, that's not too bad, because typically the bulk of our estimations are going to be within $5,545.49. And then almost all of them should be within standard 2 standard deviations, which this definitely falls within plus or minus 2 times $5,545.49. So that's the S value. The S value has units and it's dollars for this case, but it does have units. The R value does not have units. Apologize for the length of the video. I hope it was helpful. If you have any questions, you know how to get a hold of me. Take care.